Second classic problem of synchronization is reader writers problem. We have got the database. It is shared among n number of concurrent processes, that is reader processes and writer processes. Reader processes, they can only read the database, they do not perform any updates on the database. Writer processes, they can perform both a read and write operation on the database, that is they can update the database and at the same time they can read the database. Here the problem is it allows only multiple readers to read at the same time, and only one single writer can access the shared data at the same time. That is, multiple readers are allowed to access the database concurrently, but if any one of the writer process is writing and data onto the or updating and data onto the database, no other reader or writer processes are allowed to access the data from the database. And how it is solved by using a semaphore, that we will see now. And it uses three semaphores. One is a mutex semaphore. It provides an mutual exclusion among the processes and it is initialized to 1. And the next semaphore, that is WRT or write a semaphore, it is initialized to 1 and it is also an binary semaphore. And next semaphore is an counting semaphore, it is initialized to 0. And this read count semaphore, it is usually it is used to count the number of readers in the critical section and permits the writer to enter when it becomes 0. When the read count becomes 0, it indicates that no reader processes are interested in the critical section parts. In that case, it can, if any of a writer process interested to update the data in the database, they can enter into the critical section. And that count, read count, number of reader processes currently reading the data from the database, that count is maintained by one of the semaphore, that is a read count. And this is the structure of the reader process, and below is the structure of the writer process.